So here's an example of a complicated circuit of capacitors. And what you need to do is find out how much energy is stored in this little guy right here. Let's make this our example problem. And look, here's a hint. When they want to know either the charge or the voltage drop or the energy stored in one of the capacitors, you pretty much have to find them all. I mean, you have to kind of solve the circuit. This is for, Evan and Robin. These are for you. Okay, so here's something that's really a handy thing to do. And by the way, this will be good when we get to resistors and other, complicated circuits. Make a chart. Make a chart, and then you're going to use this chart, and you fill it in as you go along. Oh, I forgot charge. Oops. So let's say, because you're going to be figuring out a lot of stuff with little tiny equations, and you need a place to write it all down. So here's what's given. I've got these capacitors arranged like this, C1, 2, 3, 4, 5, and 6. I've got the capacitances are given here in microfarads, and I want to know, what's the voltage across each capacitor, what's the energy stored, what's the charge in it. Maybe I can stop when I get to U2, but you'll see you can fill this whole thing in. So make a chart. Then what you need to do is you need to break the whole thing down. You need to figure out the equivalent capacitances for the whole thing, and then you can work your way back. So here's what we're going to do. We're going to work our way forward by taking this and reducing it slowly down into one capacitor, and then we're going to back out. And when we back out and come back to where we started, now we'll have the information that we need to fill, to solve and fill everything in here. Now there are some things. So I'm going to solve it over here, and I have to write kind of small. So if you can't see, move up to the front if you need to. Well, there are certain things you have to keep in mind. If you have capacitors that share the same voltage,
then they are in parallel. So that, in other words, like V1 equals V2 equals whatever. Now, V1 does not equal V2 in this. This is just in general. And then, but if they're in parallel, remember that Q1 plus Q2, you add the charges together. And then if they're in parallel, C equals C1 plus C2. So I just kind of write these down, keep these in mind with these little facts. If they're in series, well, then they're going to have the same charge. Q1 will equal Q2 if two capacitors are in series. But the total voltage will be V1 plus V2. In other words, the voltages add. And then the equivalent capacitance will be 1 over the equivalent capacitance is 1 over C1 plus 1 over C2. And then, of course, we know that capacitance is equal to the charge divided by the voltage across that capacitor. So knowing these facts about capacitors, we can solve this guy right here. And that's what I'm going to do. I'm going to be moving, using these little facts to solve this circuit. Okay, so let's get started. Look for stuff that's in parallel. Look for stuff that's in parallel. How do you know if two or more capacitors are in parallel? It doesn't matter what the shape of the wires are. What matters is, do they have the same voltage drop? Look at these two. They have the same voltage drop. To get from here to here, it's the same voltage drop. Okay, so I could go C2, comma 3 is equal to C2 plus C3. C2 plus C3, that's 1 plus 3. is 4 microfarads. So the equivalent of those two is 4. Then look at these two right here. C4 and 5, they're in parallel. C4 plus C5, that's 6 plus 2 is 8. So I go C4, 5 equals 8 microfarads. Now look at how I'm doing these subscripts, okay? Now I redraw the circuit. Now that I've broken, I don't see anything in here that's in series yet. That's just two capacitors in series. So I take the time to redraw the circuit. And so now I've got C1, and then I've got C2, 3, and I've got C4, 4, 5. These two over here. And then I've got C6. And then there's going to be 20 volts between here and here. Now, what have I got here? I've got capacitors in series. So now I'm going to combine these. C1, 2, 3 is going to be equal. Well, these are in series, so to get the equivalent capacitance, I'm going to use this one. I'll just go 1 over C1, which is 1 over 4 plus 1 over, and then the C2, 3 is 1 over 4. So that's 1/4 plus 1/4, that's 2/4. You flip it over, you get 4 over 2. So this is equal to 2 microfarads. So these guys right here is 2 microfarads. And what is C4, 5, and 6? Well, it's 1 over, we said 4, 5 is 1 over 8 plus 6 is 1 over 8. Oh, that's kind of convenient. That's 2/8. That's 1/4. Flip it over, it's 4 microfarads. Now, you might get a circuit where you can't do this in your head. That's fine. Just get your calculator out and use that reciprocal button. You know. So now I've broken the circuit down into 2 capacitors. And so now this is C1, 2, 3, and C4, 5, and 6. And now I can get the equivalent capacitance of the whole thing, because these two now are in parallel, which means that I just add the capacitance. So the equivalent capacitance of the whole thing is this plus this. It's 6 microfarads. Now this was as far as the example problem in your book went. But now let's take it further. What if you need to go backwards and you need to figure out how much charge there is? Well, if I look at this, I know that this is 20 volts. It's given that from here to here is 20 volts. So can I figure out how much charge is on here? Yes, I can. I can go, okay, the charge on 1, 2, 3. Well, I just use this equation, C times delta V. Well, C1, 2, 3 is 2 microfarads times what? 20 volts. And that's going to be is equal to what? 40 microcoulombs. Okay, so on here there's 40 microcoulombs. But remember how we broke these down? These go up here. So what does that mean about these two? If this has 40 microcoulombs, these are in series. And what is true about capacitors in series? They have the same charge. So C1, now we know how much charge is on C1.
40, let's just put microcoulombs up there. So now we can start filling it, stuff in. Oh, let's go ahead and finish C1. Because now we know how much charge it has, and we know what its capacitance is. Okay, C1 has 40 microcoulombs. Let's figure out what delta V is. What is delta V1? Well, delta V is Q1 over C1. And Q1 is 40 microcoulombs. And what is C1? 4 microfarads. So what's 40 divided by 4? That's 10 volts. So we know now that C1 has 10 volts. Oh, but look. If this is 10 volts, what does this have to be? That has to be 10 volts as well. But if this is 10 volts, now I'm going to go back over here. C2 and C3, this is equivalent of C2 and C3, but they have the same voltage drop. So now I know that C2 and C3 both have voltage drops of 10 volts. But remember, what I really wanted was how much energy is stored on capacitor 2. Well, now I know what its capacitance is, and I know what its voltage is. So what is the energy equation? 1/2 C delta V squared for 2. So that's going to be 1/2, and what's C2? 1 microfarad. And I'm still on camera. Okay, good. And then what's its voltage drop? 10 volts squared. So that's 100 times 1 divided by 2. So that's going to be equal to 50 microjoules. Right? We keep the micro. And that's my answer. Now, look, it turns out that I didn't need to fill out the whole chart. But I think you can see by the way I'm breaking these down and using these facts, I can fill out this whole chart. And you know what? It's kind of fun. It's like a little puzzle. But you can always check your work, because you always know, hey, the voltage drop going from here over to here, voltage drop has to add up to 20. This one's a little bit contrived because not contrived, but it's too bad that these voltage drops were different. This is 10 volts and this is 10 volts. These two both had the same capacitance, didn't they? This was 8 and 8, so they're going to have the same 10 volt drop as well. But they'll have different amounts of charge and energy on them. And that's how you work a problem that has multiple capacitors in it. Look for things that are in parallel, and then look for things that are in series. Break them down. Don't be afraid to redraw it. Be methodical. Keep track of things very carefully. It's not hard. It's just there's a lot of stuff. So you got to organize your information. So those of you that are really organized, you're going to be good. You're going to get through these problems and you're going to like them. Those of you that are a mess, okay, I'm kind of naturally a mess. Look at my room, all right? So what I have to force myself to do is to take the time to draw a little chart, take the time to redraw the circuit and break things down, take the time to remind myself of what these facts are for parallel and series circuits with capacitors. This could be on an equation list right here that you keep while you're doing your homework, and you'll get through the problems. One other thing, sometimes you'll see some weird stuff drawn like this, you know, with a diagonal in it. Something like that.
Well, guess what these capacitors are? Are they in series or parallel? They're in parallel because all this stuff is at one voltage and all this stuff is at a different voltage. It doesn't matter what the wires look like. You should see the wires on a robot. It's a rat's nest, you know, right? I mean, you guys will get it right but I mean, to figure out what's in parallel or what's in series, it doesn't matter what shape the wires are. You say, okay, all this stuff is at one voltage, all this stuff is at a different voltage, therefore they're in parallel. Okay? All right, that's all.